This video will cover managing your visualizations in RStudio. By the end of this video, you should know how you can use R variables to store and manipulate ggplot visualizations, how you can create an image file from a visualization, how to display a visualization in an R Markdown document, and how to close all the open visualizations you have in the viewer window. The code used in this video is available on the Learning Management System. We're going to use the Iris dataset, which is built into R. So far, when we've used ggplot, we've created visualizations, and they've appeared in the viewer window. But how do we manage visualizations? And importantly, how can you share them with other people? Visualizations made with ggplot2 are R objects. What this means is you can store a visualization in a variable using the assignment operator. When you store a visualization, it doesn't display in the viewer window, but you can view a stored visualization using the print function on that variable. This works in R Markdown as well. So let's go ahead and store some visualizations and variables. Again, your visualizations are going to use the tidyverse, so you should load that package first. We're going to save some visualizations to files today, so I'm also going to set the path to the folder where I'd like to save those files for later. Again, sticking with my best practice of keeping this information at the top of your script. So the way we've made visualizations up until this point is we just use the ggplot command, add some layers, possibly some other information. Running that code, you see the output shows up in the viewer window. Instead, you can take that exact same visualization and store it in a variable. That's what this piece of code here will do. You notice I use the assignment operator at the end, and I'm going to store it in a variable viz.1. I run that bit of code. You see I have a new variable up in the Environment Explorer, viz.1. And you'll also notice that the visualization in the lower right-hand corner didn't update. You can tell because I changed the title of the visualization. If I'd like to display that visualization, I can just use the print command on viz1. And what you can see is the output window updates now with this new visualization, example 2. So why might you like to store visualizations in variables? Well, just like in R, where you can type 2 plus 5 plus 8 and get the result 15, you can also store 2 plus 5 in a variable. We'll call it var1. Take var1, add 8 to it. You'll get that exact same result, 15. You can do the same thing with visualizations, where you create part of a visualization, store it in a variable, and then later add additional information. So how might this work? I have some example code here where I create a visualization using the geom point geometry. I store all of that in a variable called viz1. I then take viz1 and I add a geom line geometry to it. What that will do is draw a visualization that has both the point geometry followed by the line geometry. So there may be a lot of times where you want to start with a basic visualization and modify it in a couple of different ways. And storing a visualization in a variable lets you make a basic visualization, add more content, but save yourself a bunch of typing. So let's take a look at adding additional layers after storing a visualization in a variable. So if you remember earlier, we stored this visualization in a variable viz.1 and printed it out. It's still in the lower right-hand corner of the viewer window there. But now let's take that visualization, viz1, and add a line geometry to it. So again, what I do is I take that variable viz1, I use the plus sign, I add the geom line geometry, I set the aesthetics for that geometry as well, and then I'm going to store that in a variable viz.2. Let's run that bit of code. So you'll notice I run that. A new variable shows up in the Environment Explorer. Nothing showed up in the viewer window because again, I stored this in a variable. So let's print it out. I run that, and you see now my visualization is updated to include both the point and the line geometry. So there's other reasons you might like to store your visualizations in variables. Importantly, drawing a visualization takes computer time. If you're just planning on saving an image of a visualization to your disk, you don't actually need to draw it in the viewer. Assigning it to a variable skips the drawing part, and it can really speed up your programs. This will become a big deal if you're trying to draw visualizations that have thousands, tens of thousands, or millions of points in them. So speaking of saving visualizations to your disk, there are a couple of different ways to do this. The first is that you can load and save a visualization object just like a tibble or any other data in R using the write RDS function, and then read it back using the read RDS function. This leads to a workflow that you might use for adding visualizations in R Markdown. What you might do is create a visualization in an R script, save it to an RDS file, then later in your R Markdown document, you may load that RDS file, put the visualization back in memory, and display it in the document using print. Again, the reason that you might do this is drawing visualizations takes a long time, and you only want to do it when you're actually rendering the R Markdown document. RDS files aren't always your best solution though. An RDS version of a visualization is going to contain all of the information needed to create it. This means a record of every data point that's in your visualization. This can lead to very large files if you're creating visualizations from big data sets. Additionally, only R can read RDS files, so if you're trying to share your visualization with other people, they would need to have R installed to be able to read it. In these cases, you might rather create an image file from your visualization, which is just a picture of your visualization stored in a common image format. ggplot makes this very easy. There is a function called ggsave that will take your visualization and convert it to an image file on your disk. This function takes two arguments. First, a path to the file where you would like the image saved. And second, it takes a plot argument, which is a variable containing your visualization. ggsave will automatically determine the image file type from the extension that you give the file name. Common extensions are PNG, JPG, and PDF. We'll talk about what each of these might mean. If you just use ggsave with a file name, it's going to save the most recent visualization that you created. So first, let's take a visualization and save it as an RDS file. What you can see here is I have the write_RDS function. I give it the variable viz.to, which was that visualization we made in the last example. And then I give it the path where I'd like it to be saved. Here, this is example2.rds in the documents folder that I have set up here. I'll just run that bit of code. There's no result returned by R. However, if you look in the folder that I have set up here, you'll see that there's a file called example2.rds. This is the file containing that visualization object. I've saved that visualization to the disk. At some point, I might like to reload it. I can do that using the read_RDS function. I do that here, where I provide the path to the file that I just created, and then I'm going to store the contents of that file in viz.to.copy. I'll run that. You see in the Environment Explorer, I have a new variable, viz.to.copy. And if I print it out, you'll see that a new visualization appears that looks exactly like the old one. You might also like to save images of these visualizations. You can do that using the ggsave command. So I have two examples here. In the first one, I'm going to save it as a PDF file. Again, I use the ggsave function. I provide a path where I'd like it to be saved, and then I provide a variable containing the visualization. I can run that bit of code. You'll notice R tells me how large the output file it saved was. It's 9.56 by 5.83 inches. I can also do the same thing, saving it in the PNG format. This is a different image file format. Running that same piece of code, R again gives me a little bit of output there, confirming that the file was saved. So you might be wondering, when using ggsave, which is the best file format to use? There's multiple options because there's not a single optimal file type. PDFs make images that scale very well without becoming grainy, but the image files themselves can become very large and take a long time to load for complicated visualizations. So think things that have a lot of layers or many data points. PNG and JPG files are going to load quickly regardless of how complex they are. But they're basically like taking a picture with your digital camera, so they're going to become grainy if you start to zoom in on them. Here, I've opened up one of those image files as a PDF. You can see it's a faithful reproduction of it. As I zoom into the image, everything maintains its fidelity. You can see these perfect circles stay perfect circles. The lines stay very perfectly straight lines. Here, I've opened up the PNG version of this visualization. At this scale, it looks very similar. But now notice, as I start to zoom in, the image starts to look very grainy. The lines are jagged, there's jagged edges in the circles. This is a major difference between PNG and PDF files. PNG files will tend to get grainy as you zoom in. PDF files won't. The downside to PDF files is the files can get very big and they can load very slowly when you have very complicated visualizations that have many layers or many data points. The last important point with managing your visualizations is how to deal with them after you've created them. Every visualization you have open in the viewer window consumes memory. This can start to become an issue when you have a lot of complicated visualizations open, or if you've been making visualizations for a long time. You can close visualizations individually by pressing the red X icon in the viewer. Sometimes it's convenient to close all of them, and you can do that by typing dev.off with 2 parentheses into the console. This is going to close every open visualization. So again, looking at this in RStudio, if I'd like to close the active visualization, I can just press the red X. R will ask me if that's okay, and that closes the current visualization. However, we've made a few visualizations in this example. If I'd like to get rid of all of them, I can just type dev.off into the console, press enter, and it closes all my visualizations. So this should provide you with a good overview of managing your visualizations in R.